Welcome to Chemistry with Mr. Brazil. Today we're going to look at Charles' law and how to apply his equation. So what Charles discovered was volume is directly proportional to temperature. In other words, it's a linear equation. Volume is equal to some constant. It's not K like Kelvin, but constant or slope times the independent variable temperature. In other words, if we were to do a ratio of V over T, it's equal to this K constant, some constant. Well, if I have this two balloon condition here, where it's the same balloons, not two separate balloons, but the same balloon, this 1 liter balloon at 298 Kelvin, and I'm going to talk about why we need to have Kelvin, is kind of cooled down, or I shouldn't say kind of, cooled down, either in a freezer or with ice, to 0.5 liters at 149 Kelvin. The ratio of these two numbers, 0.5 over 149, is equal to the ratio 1 over 298. The two have the same ratio. What Charles discovered is the condition of the first one, V1, T1, is equal to the condition of the second setup for the same balloon, same number of moles. We never change the moles. V2, T2. The two are equal. Now the question is, why Kelvin? Well, first of all, Kelvin, at 0 Kelvin, all matter has no kinetic energy. All kinetic energy is gone. With that in mind, a lot of us keep thinking, oh, 0 Celsius, ice, water is frozen. There's no movement. Well, no, there's some kinetic energy. All solids have kinetic energy unless they're getting very, very, very close and at negative 273 degrees Celsius. All kinetic energy goes. So if you were to plot the energy reduction, it would all end at negative 273 Celsius. In honor of Kelvin, that is 0 Kelvin. And therefore, water freezes at 273 Kelvin. Notice that the two units are different. I mean, not the units, but the numerical value is different. But the change from 0 degrees Celsius to negative 273, take the absolute value, that's 273 units. Well, from 0 Kelvin to 273 Kelvin, that's 273 units. In other words, the change, the delta T, the change in temperature in Celsius, is equal to the delta T in Kelvin. But the numerical value for a condition like 0 degrees Celsius, the two values are different. Next, memorize how to convert from Celsius to Kelvin. Okay, if you have Celsius, add 273. And if you want to go back to Celsius, subtract the 273 from the Kelvin unit, okay, or the Kelvin value. Now, with that in mind, there's a couple things we need to talk about in context to introductory chemistry. First, a person cannot go beyond, meaning 0 volume. In other words, you can't go to negative volume. Once you fill a box, that box isn't going to gain any more volume and you can stuff more stuff into it. There is no negative volume. It doesn't exist. Also, a balloon, if it has one atom of a gas and it's in there bouncing around, it has pressure. It's super low, really, really low, but there's pressure. But remove that atom, there is no pressure. There is no negative pressure. There's nothing in there. So there's not a negative pressure. That doesn't exist. I know that in the auto industry, they may use that, but that's to show direction of where a gas is going. But that's a different story. But there is no negative pressure. And then also, Kelvin is the proper temperature to use because it actually measures the absolute change in energy or loss of energy. Okay, degrees Celsius, Fahrenheit, they do have 0, but they go to negative, but that's based on water, okay? Not on the physical property of matter. So let's do an example. We have this 1 liter balloon at 25 degrees Celsius. It is cooled down to a negative 124 degrees Celsius. What is the new volume? Now, see the word at? That at associates the 1 liter with the 25 degrees Celsius. That would be my V1 and my T1, while the negative 224 is the T2. Yes, we could rearrange that to V2, T2, but since this was the beginning, I like to start V1, T1. If you get confused, always write the equation the way you know it. You could always list these, okay? Or you can label it right in the question, right? V1, T1, T2, so as not to get confused. Always rearrange your algebra. Okay, write the equation the way you know it. Rearrange the algebra. Always practice good algebra skills. Then, and again, don't forget to convert to Kelvin. Then put your numbers in. Okay, rearrange the variables first, then place your values. Do your conversion if you want to in the problem or before the problem, but by putting the numbers in after, you can see units cancel and make sure you're in the right unit that it's going to be, liters. So in other words, this is going to be 0.5 liters, much like I shown before, okay? So algebra first, numbers next, okay? And remember, the at associates the two values together, the ratio that belongs together. Now, real quick look. Let's say we did use something with Celsius, okay? Here's a negative 21 degrees Celsius. We want to find this new volume at 90 degrees. Well, we rearrange our equation, we plug in our values, and whoops. We have a negative value. The Celsius are going to cancel, but we're going to end up with a negative volume, which does not exist. So make sure you're converting your temperatures to Kelvin. That's one of the biggest mistakes beginners do. Okay? Enjoy chemistry. Keep practicing. Until next time. Bye.